Okay, demonstration on how to obtain reliability coefficients using SPSS. And for this demonstration, I am going to use two research questions, dummy research instruments, where I have cluster 1 with 1 to 7 items, and I have cluster 2 with 8 to 15 items, which means that for research questions 1 I have 7 items, and for 2 I have 8 items respectively. Now I would quickly go to my SPSS environment where I have already set up the data for the sake of time, and what we're going to do is to walk through what we have here briefly and then go to our main purpose, which is to generate the reliability coefficient of questions 1 and research questions 2 respectively. Now here we have, under this view, we have the items 1 to 15, and I have particular interest about this and that. Let's work with this briefly. These are the items as we are presented in the instrument: 1 to 7 for the research questions 1 and 8 to 15 for the research questions 2. And here I have the value where I assign values to my response scale and response options. And here I have 1, which represents very low extent, 2 low extent, 3 high extent, and 4 very high extent. And what is happening here is all equally happening in all these boxes that corresponds with 15, item 15, 13, 12, and all the items across this very environment. Then from here I want to discuss this briefly. Here I decide to measure all these items with ordinal scale. Why? Because I have 1 to 4 Likert measurement, and they are not equal. 1 is not equal to 2, nor 2 equal to 3, and 3 is certainly not equal to 4. Therefore I choose to use ordinal, and that is that. I've explained this, that, and that. The rest are not that significant to what we're doing. Then the data view, I already did the data input so that we can save time. This is a short video. Now I have items 1 to 15 according to the research question instrument, and I have 1 to 20, which represents the number of people that responded to my instrument. They are 20 in number, and all these numbers are their responses. I can convert it to the response option, but it's something as leaving it at the number. So once this is done, once you've been able to enter all the responses from the respondent, then we move to the main purpose of this video, which is to demonstrate how to generate a reliability coefficient for research questions 1, 2, 3, 4, 5, as the case may be. Now I move to analyze. From analyze, I can see a whole number of statistical tools, but in this case we are particularly interested in using scale. And from here we move to reliability analysis, and here we are presented with the items that we are working with, and my interest is to get for research question 1, research question 2, and the overall reliability coefficient, which is the combination of research questions 1 and 2. So here I pick this item 1 to 7, which represents RQ1, and choose if there's anything I want to choose. From here I pick mean and continue. OK, and in a few seconds I'm presented with the result of my analysis, which awaits my interpretation. in a nutshell, the first table here reads that we have a processing case which 20 respondents were all included in this analysis. None was excluded, and the percentage is 100. Then for the second table, we have the first column, second and third column. First column is what we are particularly interested in, where we choose or we can see our reliability coefficient to be 0.72. We are not choosing this because we do not conduct a standardized test. This very column signifies that the number of items for this very analysis is 7, and for the last table it simply shows the mean of how the respondent did respond to the instrument with respect to result question 1, and the number of items that they did respond to. Now the second action is to go back to the scale and conduct for our second research question. In this case, we are picking 8th item to 15th item and move them to the items box and analyze. And here, once again, we are presented with the same table like the first one. The same 20 persons responded. This time around, you can vividly say that the cluster reliability coefficient changed. It is no longer the same with the first one, right? But it's still okay. It is still very high. It is positive, certainly, and it signifies that the instrument or that item, or that cluster is okay, is good for the main data collection for the research in question. And 8 signifies that the items are now 8, not 7 for the first one, and something is happening here. You can see the mean of how the respondents did respond, and the number of items that they responded to. And the last, but certainly not the least, is if we go back to scale, for us now to see how to generate the overall reliability of any number of research questions that you're working with. If you're working with 10, no problem. Here we're working with 2. So I move to analysis and I'm presented with the result. Similar to the other one we've done before, we have 20, and the reliability coefficient this time around is 0.60, while the items that respondent did respond to is now 15 items. That is all the items summed together. Now, this is how to do or conduct the reliability analysis for any number of such questions, and come up with the results, the overall reliability coefficient. Then before we end, I want to make a little clarification about what people think. It is wrong to believe that this very overall coefficient is the average of the first cluster and the second cluster. It is wrong. It is not the average of the first and second, and I did little demonstration to maybe see if we can throw more light on that, because I did make the overall of this, the average of these two coefficients, which is 0.72, 0.62 for 1 and 2 respectively, and I did the average with Excel application, and the average is 0.675, which is not equal with what? 0.67. So it is wrong. The idea that the average, the overall reliability coefficient of number of such questions is the average of those coefficients. No, it is wrong. Thank you for listening.